And this, ladies and gentlemen, is probably the best looking PCB I've made in a long while. Greetings and welcome back to Random Tronic. My name is Chris and today I will be playing with making a PCB using the toner transfer method from a laser printer, print out on a piece of paper, get it onto a PCB using some heat and etch it and hopefully get a good quality PCB. I have been experimenting with different methods of DIY making PCB, and that's one of the reasons why I made the pantograph and started trying to isolation mill and use a pen to transfer the image, and the results are okay. But all in all, using the pantograph for that reason is a task on its own. It takes quite a while to get a PCB transferred manually, so what if I want a PCB right now, or maybe in next 10-15 minutes, half an hour or so? There is a quicker method, and that is the toner transfer. So essentially you'll print out a PCB on some paper that's suitable for the purpose and then straight to etching, pretty much. This is the method that I have been using a long time ago when I was playing with electronics as a kid. And now I'm getting back into it because it's fun. Toner transfer method has got a lot of variables. So there is the type of toner that you're using, the brand name of the printer. I've been reading that apparently one brand is better than the others. Then the medium that you're using to transfer the toner. So very often people recommend using either a glossy paper from a magazine or a inkjet photo paper or overhead projector transparencies, or you name it. There is a lot of it. Today, because I haven't got a laser printer, I've designed a PCB at home and then I printed it at work. I've printed 2 copies of a PCB layout. That should be enough for today's purposes. It's 2 copies of 8 copies, so it's kinda 16 papers, like the overhead projector transparencies and the photo paper and special transfer papers and all that. They are not very expensive, but essentially they cost quite a bit of money. Usually you pay a couple of pounds, couple of dollars per sheet. That's still quite a bit of money, especially if you want to make, you know, just random PCBs for random little projects. Nowadays you can go on eBay and get a kit of PCB, a bag of few parts, and usually the price is £1, £2 or $2. You know, it's really cheap. So essentially making a PCB at home should be less expensive, and when you're buying an overhead projector transparencies or a photo paper, the cost quickly adds up because you know, it's quite a bit. I experimented purely by accident with something different, and I'll come to that in a moment, and I think the results will be quite promising. Yes, I found this in the kitchen. It's a baking paper from Lidl. I think this one came. It's a roll of sheets. The sheets are roughly A3 size, so you get a little bit over 2 A4 sizes, A4 sized sheets out of one sheet. I've printed on it because originally I took some photo paper that I had, a really cheap one from Poundland, took it to work, and let me show you what it looks like. This is the PCB that I've printed on just normal paper, and as you can see, it's printed nice. Now it's a little PCB that I've done really quickly in KiCad, just for the purpose of testing this. And then I thought, okay, that turns out okay. Let me stick a sheet of photo paper, and this is what happened. So as you can see, the photo paper didn't stick to it at all in some of the places, and it just rolled off, and mirror image later on because the roller was dirty from the toner that didn't stick to the paper. Anyways, it didn't work. I tried it twice with 2 separate sheets. So then I came across this baking paper and I thought, let me try that, because it's, you know, it's thin. So this will aid the heat transfer from the rollers in the laminator, but it also should release the toner very easily after transferring. So the toner technically should stay stuck to the copper. So I've made 2 sheets like that, and it's the same sheet like before. After printing it out once, I have covered the place where the image was printed out with just a sheet like this of that paper. And this is how it turned out. This can be easily scratched with just finger, and the toner comes off of the paper. So I think that promises really good results, because in essence we want the toner not to stick to the paper but stick to the copper. So I'm excited to try that out. Come and join me. I had to put this piece of baking paper on top of it because I was concerned that this will rub off. I'll show you in a moment what I mean by that. And yes, masking tape like this is safe to put through a laser printer. You don't need a Kapton tape. Masking tape is just fine. It will be fine when you pass it through a printer or when you pass it through a laminator. Nothing bad will happen. Now I've tried putting just a sheet of baking paper itself through a printer, and that resulted in a horrible jam that I had to take almost half the printer apart afterwards. There it is. Now, as you can see, this part of the circuit is damaged. There's 8 boards on here, but even the slightest scratch, you see, removes all the toner from it. So the toner adhesion to the surface of this paper is really low, and this is good actually for this purpose. So I'm just going to cut out one strip. I've made so many copies because yeah, I didn't know how it was gonna go, whether I will have to experiment maybe with how many passes through the laminator. So I figured I can just make a bunch and try it out. I did a few tests off camera, not with this PCB and not with this paper, just some random lines that I've printed another day at work. And I came to a conclusion that I do need a laser printer in my life. So I will be probably buying a laser printer later on this week. I have my eyes set on a Brother printer because A, it's really cheap, and B, the toner, the supplies for it are extremely cheap compared to anything else. Now, a lot of people have said online that Brother printers are really bad for toner transfers, and I think that's not exactly true. I think there is a lot of other factors to it, like the cleanliness of the PCB and what sort of media are you using and the temperature and everything else. Every printer is good for toner transfers, I think. It's only a matter of getting the other parameters right according to the toner that you're using. Let's see how this goes. So this is a virgin test. I've not tried this paper, this printer, and this, by the way, was a HP printer, but with a non-original toner replacement cartridge. And that's another thing that I've been reading out on the internet, that you're not supposed to use non-genuine toner in the printer if you want to do toner transfers, because it doesn't work. So we're about to find out if that is the case. So I've got a piece of PCB cut out of the PCB layout straight from KiCad on a baking paper, and let's prepare the PCB. And I think this is the most important thing in the whole process. So I've already sanded the PCB very lightly with some 600 grit paper. I've got just steel wire brush, and I'm gonna give it one final scrub beforehand. And after the scrubbing, I'm gonna pay attention not to touch the surface of the PCB, and some acetone will do the rest of it. So this is from Poundland in UK, 1 pound, 99% acetone. This is what we want, so almost pure acetone. I don't think you can get 100% acetone. There's always some impurities, but yeah, this should do with removing any other organic or inorganic compounds from the surface of this. And acetone is really cool because it evaporates instantly. And there we go. I'm comfortable that this is really clean right now. Masking tape. So I've got a piece of masking tape over here, and I'm going to use that piece of masking tape to hold the design or the little template on top of the PCB. Now, how do I do that? I think one important thing is this is the direction that the PCB is going to be going in. So it's important that this edge over here is where we've got the tape. But at the same time, you don't want any tape on the edge, because tape adds to the thickness, so the rollers wouldn't be pressing on it with even pressure. Ideally, I would have a little bit of sacrificial surface over here, and with a PCB prepared this way, after the first pass in this direction, it should completely adhere to the copper underneath. And here is an old used and abused laminator, generic brand. This one is WH Smith, but this thing is being sold all over the world with different brand names. This is the most basic generic thing that you can get, and also the cheapest one, which is also good. This I'll have to wait until it gets up to a temperature. What I recommend, I've noticed that initially it will click off. There is a thermostat, I think, on this side. What I'm going to do, I'm going to wait until the LED comes on, then comes off, then comes on again. That means one heating and cooling cycle will be complete. I will make sure that the entire roller inside on the entire width are fully up to the temperature. So it has been a while now. Laminator has heated up properly. I've heard the relay click in and out 4 or 6 times, so it's been through a few cycles and the case is relatively hot, so I'm assuming it is up to the temperature. So let's get our design. Now another trick is to put it through the laminator in different spots so the PCB can suck out as much heat as possible. I'm going to start in the middle. That goes in, and after first pass the PCB design should stick nicely onto the copper clad. Okay, yeah, it is stuck on, so let's put it through over here. The thickness PCB helps with the pressure because it spreads the rollers inside quite a bit, so there is a good amount of pressure applied to the PCB. I think at some point I will have to take this apart and modify it. There's 2 ways you can modify the laminator like this. So one would be to increase the temperature, which is relatively easy. There is just a thermistor on there that you have to add a couple of resistors to it to make it go a little bit misreading. Another way to do it would be to decrease the speed of the motor inside, and that should be somewhat simple as well. That should make sure that you'll need less passes to go through the laminator. Okay, let's make this a last pass. I've done in total about 12. I figured it's not gonna hurt much. Let's try maybe simply peeling it off. I said before that the toner doesn't stick very well to this paper, and ta-da! Entire toner has transferred over. The only problem is the printer was on some economy setting and it hasn't transferred enough of the toner. Some of the surface areas are a little bit iffy. I can see some copper through it. So it's not ideal. I didn't have control over the amount of ink and whether I can literally press print only. And it's printing on default, probably the lightest setting. So yeah, I'm happy with the way it transferred though, but I'm not happy with the amount of toner that got transferred. What if I put another layer of this on top of that? I should be able to line up the design perfectly. Let's give it a try. Okay, I think I got it lined up pretty well. So let's see. If it doesn't work out, it doesn't matter. I need my own printer really. That's what I need. Now this will be the case of yes, I've aligned it well, or no, it moved slightly and the PCB is ruined at this moment. And it is the case of the latter. The PCB is stuffed. It has moved. Oh dear. But the second layer did make it really black. I rubbed it off and I'm going to do it again. That's why I got so many of those little printouts. But this time, the second one, I will do a little bit differently than before. So let's put the first one through. And again, perfect transfer. The paper just peeled off from it. So I'm really happy with the paper. It's just a matter of not having enough toner on this. For the second layer this time, I'm going to tape it on and tape it like this all the way around and see if I can get any more luck. This way it shouldn't move. So again, through the laminator a couple of times, and let's see how this turned out. Okay, I would call that a success. This looks really nice. Let me show you close. So there you go. I think that looks rather good, I must say. And yeah, it's really black. So the toner transfer method does work. And there are a couple of small things. So when I did this PCB, I did it really quickly, and in a couple of places I've went really close, kinda purposely, just to see how far I can push it. So over here, I think we are close to getting a short over here and over here. So it was really close. 0.4 works just fine. It's when I got beyond that spec, but that's not a problem. I'm going to just score those lines with a scalpel, and that should be fine. And there it is. I've cut off a few, well, I scratched off a little points where it was dangerously close, and cut off the board from the rest of the clad. Now I can put this through ferric chloride and see how will it etch. So into the bag, I've made it a little bit warm, that's why it's all wet. But let's see, will this toner hold up to the ferric chloride? And let the etching begin. And some minutes later, I think that's done. And so far, so good. So let's get this separated. And this, ladies and gentlemen, is probably the best looking PCB I've made in a long while. Let's see what's under the toner. Now, to remove the toner, there is two ways around it. One, you can just scratch it off, or just use some acetone, which will very readily dissolve all the toner and rub it off, which I'm going to do now. So there is one iffy spot on the board, but other than that, I'm quite happy. It looks rather nice. There is some residue around here. This is where some glue was left over from the masking tape. That doesn't matter. I'm going to cut that off anyways. This is really nice. Almost like I bought one. I like this toner transfer thing. This worked out even though I didn't have enough toner on the baking paper. And the baking paper, I think, is the way to go. So I will be experimenting a lot more with this. My plan is to have a lot more videos where I can just come up with random stuff and build it. I thought it would be a lot better than just buying random kits on eBay, because I think the art of making PCBs at home is disappearing slowly from existence. I mean, you can buy cheap PCBs from China or from other places, but yeah, back in the day you used to make stuff at home yourself, and that's kind of skill. That used to be kind of a skill, but now no one bothers, because you can order a PCB, fancy one with a silk screen and with a solder resist, and you can actually use, I thought about this, when I get the printer I will try that. You can make the toner transfer of the silk screen for the front to have all the component layout and stuff on it. So that's coming up soon. I can't resist really to not to drill this right now and build this circuit. And here is the PCB after drilling and after filing it down to size. Yeah, let's see if I've got all the parts for this little circuit and see if it will work at all, because I've done it in a really big rush and I haven't even done DRC on this when I put it together in KiCad. So I wonder if I messed up somewhere. And here is the board populated. I did that off camera because I was hunting for the parts in all kinds of various junk. That would have been a bit boring. And besides, in the meantime, I had a failure of a piece of equipment. My component tester, which is quite handy when you're hunting for parts, decided to malfunction, so I had to focus on fixing that. But the board is populated, so I'm going to solder it in a moment. And here is the schematic if you're interested. So it's a really simple circuit, and what we have here is a 555 timer, a few caps, a couple of diodes, a pot, a MOSFET, and an output to connect the load. Now this circuit, or the schematic that you see, differs a little bit from the population of the board. Some of the components are a little bit different. So the pot, this calls for a 100k pot. The only one I found was 10k. That's good enough, but because it's a smaller pot, I've put a little bit higher, bigger cap over here. So I've put a 1 micro cap over here, and I didn't have a 10 nano So I put 100 nano cap over here. The rest of it is the same. I guess it shouldn't matter that much. More or less it should work and do what it's supposed to do. And what this circuit is a PWM controller. So I should be able to connect a load over here to the MOSFET, and yeah, with the pot control the brightness through PWM. So let's see how well will this solder. I'm going to treat the pads with some flux. Right, let's go. Let's see how this board will put up to soldering. Okay. Alright, let's see if the thing works. So I've got a load prepared somewhere here. There it is. That's just a, what is it? 5-watt light bulb, indicator light bulb from a car or any vehicle really. Okay, a moment of truth. So if I just remember where is the positive, drain source, and source should be negative, so this should be negative. Let's double check. Positive going to the load as well, and from load to drain. So that's fine. So this is positive and this is negative, and we've got a glow, and whoa, my circuit is working off the bat. As simple as it is, this is extremely satisfying because the circuit works just like that. I like this PCB etching using toner. I will be buying a laser printer tomorrow, my own one, because I really want to do a lot more simple circuits, go in detail through the build, etching with toner transfer, and especially with that cooking paper. This is by far the best I've ever tried. It transferred really nicely. So baking paper, let's do a little bit more voltage. So sorry, there we go. This was running at 6 volts, so let's give it the full 12 volts of what the bulb is rated. MOSFET's not too hot, and here's the full power, and coming down to almost nothing, and it's drawing almost no current, under 10 milliamps. But if we go full whack, we get half an amp, and there we go. This is what PWM is all about. So it's pulse width modulation. As you can see over here, the square wave, I'm connected to the gate of the MOSFET, and the square wave is mostly in the high state, and it's got only short impulses connecting to the ground. So MOSFET is switched on majority of the time, and this is the 100% brightness of the light bulb, as you can see. But as I decrease the brightness, you can start seeing that the gaps or the time that the signal spends in the low state do increase, and at the same time the brightness of the bulb goes down. Here it would be about 50% from what I'm seeing, and we can go even more and more to almost nothing, and the circuit is kind of stable, more or less between 95 and 5%. So it's having challenges going down all the way down to 0, and at the same time going all the way up to 100%. It goes a little bit unstable. I think this can be eliminated if I tweak the value of the caps and the pot, but for what it is, it works. So I can dim a light bulb up and down. But in essence, the circuit I made over here, it was just something I could quickly come up with just to test really the PCB etching baking paper, which worked great. So So soon, I promise, we will do an unboxing of a laser printer. I think I know which model I will get. Please do subscribe if you want to see that. For this video, that's it. It's a successful build of a little gizmo. I hope you enjoyed it. For me, it was a lot of fun to put this together and test a couple of things. Thank you very much for watching. Please do subscribe for more random stuff that I will come up with. All will be electronics related somehow, I promise. For this video, that's it. So take care.